In this video, we're going to be looking at independent events. So we've gone through several types of events already. We looked at equally likely events, and events, or events, conditional events, mutually exclusive events, and finally, independent events. So this will wrap up basically what we've covered so far, tie in some gray area together. So events A and B are independent of each other if knowing B does not change the probability of A occurring. And here, events A and B are independent if at least one of the requirements are met. So either P of A given B is equal to P of A, or P of A and B can actually equal P of A times P of B. So for independent events, it's not so much that you have to calculate probabilities, but more so checking to make sure that they are independent of each other. So here, you're checking to make sure that the left-hand side matches the right-hand side. So making sure that the left-hand side matches the right-hand side. Same with the second part right here. We're checking to make sure that P of A and B can actually equal P of A times P of B. So that's the motivation behind independent events. We're making sure that both sides are equal to each other. So we're not actually calculating any probabilities. Well, we do that, but we're not finding one answer. Our answer is either it's independent or it's dependent. So to demonstrate how that works, we're going to go ahead and look at an example. So in this example right here, suppose you have a deck of 52 cards and one card is dealt face down. We want to know, and let A be the event that the card is a spade, let B be the event that the card is a queen. We want to know, are the events A and B independent of each other? And so we're going to go ahead, I'm going to go over to my whiteboard here, and we're going to show how that works. And so I'm going to quickly add a sticky note. So independent events, we need to check one of the following. So either P of A given B is equal to P of A, or P of A and B is equal to P of A, times P of B. So we have to check one of the following to make sure that they're satisfied. If they're not, then we cannot claim that they are independent. So always keeping this in mind while we solve for these problems. So here, the events have already been defined for us. So we're just going to go ahead and plug spade in for A, queen in for B. So I'm going to check that using the first method or using the second method right here. So we're checking to see if P of A and B is equal to P of A times P of B. And so here, probability of being spade and queen, we want to know, is that equal to probability of being spade times probability of being queen? Now, do we know what the probability of being spade is? So out of 52 cards, how many of them are spade? 13. Out of 52 cards, how many of them are queen? 4. So probability of queen is 4 over 52. Probability of being spade is 13 over 52. Now, the left-hand side, do we know what the probability of being spade and queen is? So out of 52 cards, how many of them are spade and queen at the same time? There is only one card that is spade and queen. That's the spade, or spade and queen. Yes, there's only one card. It's the queen of spades. And so here, we're going to multiply the right-hand side out and see if it matches the left-hand side. So 152, is it going to be equal to 13 over 52 times 4 over 52? So if you solve that out quickly, the right-hand side does equal 1 over 52. So here we can conclude that the events are independent because the left-hand side agrees with the right-hand side. In the next example, instead of using the second method to check, we're going to use the first method to check. Both methods are going to arrive at the same conclusion, even though if you check both ways, they might give you different results in the end. So different numbers in the end, but the conclusion should remain the same. So in this next example right here, let me quickly write down what we want to check. So the method we want to check is P of A given B equal to P of A? This is what we want to check, and this is just what we get from the sticky note. So this part over here. Okay, so suppose you have a deck of 52 cards. A, let that be the event that the number is greater than 10. Let B be the event that the number is a heart, or that the card is a heart. We want to know if the events A and B are independent of each other. So here, A and B have already been defined, so I'm just going to plug that in. P of A, so P of being greater than 10, given B, which is being a heart, is that equal to P of A? So is that equal to probability of being greater than 10? So if we think about it, let's work with the right-hand side first. What's the probability of being greater than 10? So out of 52 cards, how many of them are greater than 10? So you have the Jack of Hearts, Queen of Hearts, King of Hearts, Ace of Hearts. So here we're going to consider Ace as high. You also have the Jack of Spades, Queen of Spades, King of Spades, Ace of Spades, and then you're going to repeat that for the 4 different shapes that we have. And so in the end, you can go ahead and double check this, but you should have 16 cards that are greater than 10. Remember, we're considering Ace as high, so we're considering Ace to be greater than 10. Now the probability of being greater than 10, given that the card is a heart, so since we have this restriction that the card has to be a heart, our denominator must be the total for hearts. And so there are 13 total hearts in a deck of cards, so that becomes our denominator. Out of the 13 cards, how many of them are greater than 10? So here we have Jack of Hearts, Queen of Hearts, King of Hearts, Ace of Hearts. So that's 4 cards that are greater than 10, given that they are hearts. Now checking to make sure they equal each other, if you solve the right-hand side, you would get that they are indeed equal to each other. And so in this case, we also have another example where the events are independent of each other. In this final example right here, we're going to be using a table to determine if 2 events are independent of each other. Okay, so here we have our example. We want to know if the events male and card are independent of each other. And this is the table that we're using, which is the same table that we've used for the last few examples. So here it says to explain using a law of probability. When you see that, we're basically just saying that use one of these methods to check. And so don't just tell me that it's independent because you think they're independent. You actually have to check using one of those methods. So using the table is also very simple. Here we still have to find probabilities, but those probabilities are basically given to us in the tables. We just have to know how to find them. So I'm going to show how we can use both methods to check. So the first method, we're going to look to see if probability of A given B, is that equal to P of A? So that's method 1. So let's say that event A is being male, and then car, let's call that event B. So we're checking to see if probability of being male, given that they took the car to school. Sorry, this is really ugly. Is that equal to probability of being male? So we know how to find conditional probabilities from our last video, and we can do the same here. So probability of male given car, the given condition is that this person must have taken the car. So the total for car becomes our denominator, 165. Out of these 165 people who took the car, 75 of them were male. So that becomes our numerator. Is this fraction equal to probability of male? Again, we know how to find the probability of being male. That's just going to be 124 out of the grand total. So there's 124 male out of the 278 students that were recorded in this table. So we're checking to make sure that both sides equal each other. If they equal each other, then we can claim that they're independent. If they do not equal each other, then they're not independent. And if you do that, you would find that 75 over 165 does not equal 124 out of 278. And so our conclusion would be that these events are not independent of each other. So using method 1 to check, we find that the two events are not independent of each other. Now we're going to use the second method to check. The second method to check is making sure that P of A and B, is that equal to P of A times P of B? Again, we said that male is our event A, car is our event B. So specifically, we're checking to see if P of male and car, is that equal to probability of being male times probability of taking the car. Similar to before, we know how to find the probability of being male and car. In the AND event section, or in the AND event video, we know that we can look at the row or column with male, the row or column with car, and find where they intersect. In this case, male and car intersect at 75. So 75 out of the 278 students were males who took the car. And then we know how to find the probability of male. We also know how to find the probability of car. So probability of being male is 124 out of 278. And probability of taking the car is just going to be 165 out of 278. And then if you've solved that out, you should get that these two sides are not equal to each other. So 75 over 278 is not equal to whatever this is. And you can calculate that. And so our conclusion will also be that these two events are not independent. And so if you actually go through and calculate them, you would find that the numbers that we get from the second method is different from the numbers that we get from the first method, but their conclusions are the same.